Vectors in the plane. Before we get too deep into multivariable stuff, we want to look at the spaces in which we'll be dealing. For right now, for this section, we're going to be looking in the plane, this two-dimensional space, sometimes abbreviated as R2. This you can think of as R times R. It just means that there's a first variable that's a real number and a second variable that's a real number. So this is just the set of all points, x and y, so that x is a real number and y is a real number. So you've been dealing with this for quite a long time, throughout all of calculus at least. This is just saying the plane. So vectors in the plane are given by components, an x component and a y component. So let's, for our first example, let's look at given 2 points, determine the vector. So let's say we wanted to find the vector that started at 2, -1 and went to -3, 4. So just a rough schematic of what this looks like. We've got the point 2, -1 and then the point -3, 4. So we have the vector that's moving from our starting point to the terminal point, this vector right here. Now to get this vector, I notice that it's moving to the left, so I know its x component must be negative. And I know that the farther apart these 2 points are, the larger the vector should be, the bigger the change in the x should be. So the components of this vector, the x component of this vector, should be the difference in the x coordinates, and the y component should be the difference in the y coordinates. So if we subtract the x coordinates, we have a choice. We can either do 2 subtract -3 or -3 subtract 2. As I said before, this vector is moving leftward, so I know this needs to be negative. And also, as we go from our starting point to our terminal point, the vector is moving up, so I know the delta y has to be positive. So the only way that can happen based on these is that we take the terminal point and we subtract the initial point. So given 2 points, we take the terminal point and we subtract the initial point. So our vector that joins these 2 points will have components. We'll subtract the x's, so -3 subtract 2 is -5. We subtract the y components. 4 subtract -1 is 5. That's the vector joining those 2 points. Now we have certain operations we perform with vectors. The first one is length, or sometimes noted as magnitude, or in some more advanced settings, the norm of a vector. So the magnitude of a vector is written with these double absolute value bars. And if we want to know the length of this vector right here, this is a right triangle, so we can just use the Pythagorean theorem. So what that comes down to is that this is the square root of the x component squared plus the y component squared. That gives us the magnitude of our vector. So for example, for this one right here, the magnitude of our v is the square root of -5 squared plus 5 squared. That's the square root of 50, or 5 radical 2. That's the magnitude of v, the norm of v. We also have other operations that require 2 vectors. So we can add vectors. Vector addition is defined by adding the components. So let's say we had the vector 2, 3 and the vector 3, -1. If we were to add these two, we add the x coordinates to get 5, and we add the y coordinates to get 2. Subtraction